Hey guys, today we're here for video 6, mass to mass stoichiometric equations or conversions. You will need your stoichiometry map. If you don't have one, there's a bottom one at the bottom of the previous lesson. You also need your periodic table, your calculator, and your pencil. You should already have your pre-notes out and turn those over so that you're working on the opposite side and take notes on mass to mass stoichiometric equations. So for those of you who are continuing to annotate your 12.2 pre-notes, which is what you're supposed to do, you'll annotate these below where you finished the last set of notes. All right, let's begin. So what I have for you today is a sample problem, which I'll read to you and then we'll solve together. Ammonium nitrate, NH4NO3, is an important fertilizer, and it produces N2O2 gas and water when it decomposes. So here's the equation. NH4NO3 yields N2O plus 2H2O. Determine the mass of water produced from the decomposition of 25 grams of NH4NO3. What I'd like you to do at this point is to pause the video, write this whole problem down, including the equation, and then underline your known and your unknown. Take time to do that now. You should have come up with your known being the 25 grams of NH4NO3 and your unknown being the mass of water. Now I'd like you to write those out like we normally do. You have two choices. You could write down the equation and then write down the known and the unknown, the known being above it and the unknown being below it. Or you could do it the way we traditionally done it, where we've separately written the known and the unknown, but you still would need to recopy the chemical equation. Pause now and work on that. You should have gotten something that looks like this. If you did it the first method, you should have gotten this. If you did the second way, you would have gotten this. Okay, now we're going to move forward in how to solve the problem. In this case, my known was the mass, and my unknown was a mass of a different chemical. So if I look at my stoichiometry map, which is that blue page that I gave you in class, though again, if you don't have that, you can always click the link from the previous video at the very bottom. I attached it. You have your path A, then your E, then your A. So you're starting out with the mass of your known. That's your NH4NO3. You're trying to get to your mass of your unknown, which was H2O. You can't just go straight across. That's not an option. So you have to go from mass of known to moles of known, then from moles of known to moles of unknown, which in this case is H2O, and then from there to the mass of unknown. This means you're going to use two different A's, if you will. You're going to use the molar mass of your known, then you're going to use the molar mass of your unknown. But in the middle, you have to use your balanced equations to figure out your mole ratio. So conversion factor A is the molar mass of NH4NO3. That's your known. And we can look at the formula for NH4NO3 and we can see that we have 2 N's, 4 H's, and 3 O's. Now some of you are kind of stuck. You're trying to figure out where the 2 N's come from. There's 2 separate N's in this problem. We wrote them separately because these are polyatomic ions. Molar mass always comes from our periodic table. So in that case, you're going to need to look at your periodic table, find the mass of N, which should be 14.01. Find the mass of H, which is 1.008, and the mass of O, which is 16.00. So if you have those masses, you'll then multiply across, and then you'll add that all together to get 80.052 grams of NH4NO3 to moles of NH4NO3. Next, we need to focus on our mole ratio. Now, our mole ratio is always in the same format. We always are going to have the number from the coefficient here, go here, of the unknown substance. In this case, this was my unknown. So it should be 2 moles of H2O. And then the coefficient, in this case, there's nothing there, so that's 1. mole of the known substance, NH4NO3. And that's how we get this. I tried to keep the color coding consistent so that you can see that this comes from the unknown and this comes from the known. Be very, very cautious though. Do not accidentally make the mistake of putting the 25 grams in here. It doesn't go here at all. The only thing that's here is moles, which come from the coefficient. In fact, this number 25 can change to anything, and the mole ratio would actually remain the same. We have one more conversion factor, and that's conversion factor A, but the green one, so the one for our unknown. And that's the molar mass of water, which is at the top. So in this case, we have 2 H's times 1.008, 1 O times 16.00. We add those together and we get 18.016 grams is equal to 1 mole of H2O. Now we get to our setup. Our setup, we know, is going to be a known with 3 conversion factors. How do we know that? Because it takes 3 different routes to get to our end. Remember the analogy that I used in last class in terms of Jamaica and the plane. Jamaica is our destination, but how we get there is the plane. So don't forget that these conversion factors are the path that you use to get there. They're the vehicle that you use to get there. It's not the actual destination. So you don't have to do any calculations aside from what we've just done. So our known, if you recall, was 25 grams of NH4NO3. Our next question is our conversion factor A, which is our known. If you remember, that was 80.052 grams is equal to 1 mole of NH4NO3. Our challenge is, where exactly does the grams go? Does that 80 grams go on the top or does it go on the bottom? Think about it. It has to go on the bottom because we need grams to cancel here. So the 80.052 grams needs to be on the bottom and the 1 mole will need to be on top. Next, we come to our mole ratio, which we've already discussed. We discussed the fact that with those coefficients get brought into the mole ratio and that the unknown substance is on top, the known substance is on the bottom. In this case, it looks like this. Note that this NH4NO3 gets canceled by this one. And last but certainly not least, we have our molar mass of our unknown. In this case was water, 18.016 grams. Is equal to 1 mole of H2O. Question then again becomes, does the grams go on top or the grams go on the bottom? Well, in this case, grams goes on top. We need the 2 moles of H2O to cancel out. We need that moles of H2O unit to disappear. And in order to do that, we need this to be on the bottom. This also should show you that we would wind up with our answer in grams. So 25.0 grams, the grams of NH4NO3 will cancel. The moles of NH4NO3 will cancel. The moles of H2O will cancel, leaving us grams. Note that none of our numbers canceled, only our units. When we do the math for this, actually what I'd like you to do is you pause right now and see if you can do the math and see if your math looks like mine. So I have the 25.0 times 1 times 2 times the 18.016 across the top that I multiply across the bottom. That's going to get me 90.08 divided by 80.052. And when I do that, I get 11.2526, and the number keeps going on and on and on. Now, if I look back at my original problem, the 25 was 25.0. That meant it had 3 significant figures. So because of that, my final answer needs to have 3, which makes it 1.13 times 10 to the first grams of water. Keep in mind here that because I only need 3 sig figs, that 2 rounds up because of the 5 behind it. Stop here, replay the video, go back and make a list of any questions that you have that weren't answered so far, and then try the practice problem. We'll speak in class next class with this problem. One in a series of reactions that inflate airbags in cars is the decomposition of sodium azide, which is 2Na3 yields 2 Na plus 3 N2. Determine the mass of N2 produced if 100.0 grams of sodium azide is decomposed. First thing I would like you to do is to underline your known and your unknown. Pause and do that now. Of course, after you've copied the problem. This is your known, and this is your unknown. Now, take the rest of the problem from here. Remember, do not confuse your moles of known or your molar mass of your known for your molar mass of your unknown. Make sure your two A's are separate, and that has nothing to do with your E. But when you put it into your setup, it should all look just like or very similar to the problem that we just did. See you in class.